Keep with our motto that learning be a joy and teaching a pleasure. Here we are with the remote teaching and learning process to bridge the gap. Happy learning, students. Today we are going to continue with class 9 science chapter number 11 reflection of light. Topics that I am going to cover during this session are divergence and convergence of light, uses of concave and convex mirrors, Cartesian sign conventions and mirror formula. Divergence and convergence of light. Light rays from the point source of light travel in all the directions, moving away with time. Such a beam of light that is shown over here in this picture is called divergent beam of light. You can see from the source, from the point source, the light is diverging in all the directions. Whereas a convergent beam of light rays come together after reflection and refraction at a single point that is known as the focus. All the rays of light are focusing at a single point. These are called convergent beam of light rays. Concave mirror is also called focusing mirror. This is because, as shown in this picture, the parallel rays of light, they are getting focused after reflection at the point that is principal focus. The size of the image produced by these mirrors can be larger or smaller than the object, depending upon the distance of the object from the mirror. Whereas convex mirror is also called dispersing mirror. This is because the parallel rays, the incident rays of the light, they get dispersed after reflection as shown in the picture. They are getting reflected from the mirror. That is why it is called a dispersing mirror. The size of the image produced by these mirrors is always smaller than the size of the objects. Now, how will you find out if the mirror is a concave mirror or a convex mirror? The spherical mirror, which is used for shaving, is a concave mirror. When held close to the face, it gives vertical and large image of the face. If the same mirror is taken further away from the face, the image gets smaller and smaller. The mirror that is used in the cars and the motorcycles, they are convex mirrors. In these mirrors, the image that is formed of the face is erect and smaller, and it remains erect but becomes smaller and smaller when the mirror is taken away from the face. As a result, we can see the images of the surrounding also in the mirror. Thus, we can determine the nature of the mirror by studying the images produced by them. Now, let us see the uses of concave mirror. Barber shop, dental hospital. Here the concave mirror is used. If the object is placed between the pole and the focus of the mirror, an erect virtual and magnified image is obtained. It is also used in torch and headlamps of vehicles, where the source of the light is kept at the focus of the mirror. Thus, a parallel beam of light is obtained. Concave mirror is used in floodlights, where the source of the light is placed a little beyond the center of the curvature of the mirror. This gives a bright beam of light. Concave mirror is also used in various equipment which are using the solar energy, in which sun rays are reflected by a concave mirror. They come together in the focal plane. Uses of convex mirrors. Mirrors on the side of the cars and other vehicles, they are convex mirrors. Also, big convex mirrors are fitted in the shops. Let us understand Cartesian sign convention. According to the Cartesian sign convention, the pole, as shown over here in the picture, the pole of the mirror is taken as the origin. The principal axis is taken as the x-axis of the frame of reference. The sign conventions are as follows. the object is always kept on the left of the mirror. This is the left side of the mirror. We are considering pole as the origin. So along the left side, this is the left side of the mirror. So the object is always kept on the left side. All the distances that are parallel to the principal axis, they are measured from the pole of the mirror only. All the distances measured towards the right of the pole, they are taken positive. Here you can see towards the right hand side of the pole, all the distance measured are considered to be positive, whereas those measured towards the left of the pole, they are taken as negative. Distance measured vertically upward from the principal axis, they are taken to be positive, whereas the distance measured vertically downward from the principal axis are taken as negative. And the focal length of the concave mirror is always negative. You can see over here the focal length is nothing but the length between the focal principal focus as well as the pole. So it is towards the left. So it is always negative. Whereas in convex mirror, the focal length is towards the right side of the pole. So it will always be positive. These sign conventions are useful in obtaining the mirror formula. Let us see the mirror formula. Concave mirror and convex mirror as well as the ray diagram are shown in the picture. We can get the correct values of distance by using the Cartesian sign convention. The object distance, that is u. Here is u. It is the distance of the object from the pole, while v is the distance of the image from the pole. The relationship between the object distance, the image distance, as well as the focal length is called the mirror formula, and it is 1 upon v plus 1 upon u, that is equals to 1 upon f. This formula is valid for all the spherical mirrors, for all the position of objects under all circumstances. The magnification due to the spherical mirror is given by the ratio of height of the image to that of height of the object. That is m, which is magnification, that is equal to height of image divided by height of object. So this tells us how large the image is as compared to the object. So over here, height of the image is h dash, whereas height of the object is h. So it will be h dash upon h. We can also write it in terms of u and v, where v is the distance of the image from the pole and u is the distance of object from the pole. So m is equals to minus v upon u. Now u will always be positive, that is the height of the object. Why it will be positive? Because the object is always kept above the principal axis and also towards the left of the mirror. So according to the Cartesian sign, we know that above the principal axis and towards the left of the mirror, the distance is always positive. So height of the object, that is u, is always positive. Whereas this v, which is the distance of the image from the pole, right? It can be positive or negative. For virtual images, the height is positive, but for the real images, it is negative. So we can write it as m is equals to minus v upon u. This is all about today's session. Thank you so much.